Hi, welcome to Dr. Raz, the Baking Chemist, on this wonderful rainy day. I love the rain. This question is a requested question. It's on Equilibria and it's a Year 1 or AS level question. However, it will also be needed for Year 2 or A level students. Okay, let's see what we can do. The diagram below shows the effect of temperature and pressure on the equilibrium yield of the product in a gaseous equilibrium. Okay, yield, percentage, temperature, and then of course 3. So it's actually, this graph is actually looking at 3 variables: temperature, yield, and pressure. Use the diagram to deduce whether the forward reaction involves an increase. The forward reaction involves an increase or decrease in the number of moles of gas. Explain your answer. Okay, so this is a 6-marker question, so I'm assuming that's 3 marks there and 3 marks there. Okay, change in number of moles. Now, I don't know about you, but I've said this before to you. I'm a sort of a visual person, so I like to see what's going on. And so what I'm going to do, because I know they told me it's a gaseous equilibrium, I'm going to make a general equation. Yeah. Reaction equation for a gas. So all I'm going to say is, there you go, A goes to, and it's an equilibrium, so it's going to be have that reversible arrow, goes to B. Okay, and now I can see what's going on. All right, so use the diagram to deduce whether the forward reaction involves an increase or decrease in the number of moles of gas. Okay, so I'm now going to what I'm going to do is I'm going to change that slightly. Okay, so I'm actually going to put 2 here just to give me different number of moles on either side. Yeah, I know we're talking about equilibrium. That'll help me actually answer that question. Okay, so it says whether the forward reaction was an increase or decrease in the number of moles. Okay, now looking at this graph, this is a question where the examiners are actually assessing not only your mathematical knowledge but a lot of your equilibrium content as well, chemistry content. So for example, you know, they want to know whether you know and understand equilibria. Okay, so let's see. Right, increase in the number of moles of a gas. Well, in a gaseous equilibrium, pressure has a huge impact on whether, you know, the equilibrium moves forward or backwards. Okay, if there are a different number of moles. Okay, I've just arbitrarily given the products 2 moles, so more moles than the reactants. Okay, so now I'm just going to look at obviously percentage yield, because that's what I'm looking at, the percentage yield of the products. But then I'm going to look at the pressure. Okay, what happens when you increase or decrease pressure? And there are 3 different sort of pressure variables here, 3 different pressures, and they're looking at the yield for each one. Now immediately I can see that as you decrease the pressure, so look at the 50, so I'm not looking at sort of all of this curve, I'm just looking at generally whereabouts, what percentage yield does this pressure give you. And I can see, okay, just pick a point, I'm just going to pick a point here, right? So that pressure, yeah, gives you this much yield. Okay, generally this pressure gives you lower yield, but as you increase, that one gives you, sorry, as you decrease the pressure that much, so increase. So look what's happening. So as I lower the pressure even further, the percentage yield is increasing. So what that means is that if I'm lowering the pressure, the yield of this is increasing. So in what situation, yeah, will lowering the pressure increase my yield? So if I decrease the pressure, this equilibrium will try and increase the pressure, and it will only do that by moving towards the direction where there are more moles. Okay, so even though I just guessed it here, you know, just because I want to start with something, I've actually guessed it correctly, because if I in this equilibrium, if I decrease the pressure, this equilibrium will move in the direction to increase the pressure wherever there are more moles of gas. Okay, and therefore the products must have more moles of gas, because that's why my yield is increasing. So if I decrease the pressure, what's happening is the equilibrium is moving towards that direction to try and increase, because remember Le Chatelier's principle, equilibrium moves towards the direction to oppose the change that you put on it. So in other words, if I'm trying to decrease the pressure, the equilibrium will try and increase the pressure, and I can see from the graph that it's giving me in more yield, the higher yield. That means there must be more moles of the products. Okay, and therefore, so it gives me greater yield. Yeah, more B. So that means there must be more moles on the product side. Yeah, so more moles on the product side. So in other words, change in the number of moles. So the answer to that question, change in the number of moles, well, it increases. I mean, you got to write it, but I'm just putting an arrow there, but you got to write it increases. Okay, and now you need to explanation. You need an explanation. Now, obviously, I've explained it to you, so you know we just got to put it into words. Now, when this question came up in the exams, this part of the question, so change in the number of moles here and the forward reaction that was answered fairly well. It's the explanation where a lot of students lost marks because they couldn't explain it. Yeah, and this could be just because they're guessing, maybe they're not, but they just could not explain it. So now the explanation is worth 3 marks. Remember, 1 mark there and 2 marks for 2 marks for the explanation. So the way you got to explain it is that as the pressure decreases, the equilibrium shifts towards the direction which gives you more moles. Gives you more moles, i.e. towards the products, therefore increasing the yield. Okay, so as you decrease the pressure, the equilibrium will shift towards the direction which provides more moles, yeah, i.e. towards the products, and therefore increases the yield. Okay, that's your explanation. All right. Okay. Use the diagram to deduce whether the forward reaction is exothermic or endothermic. So now, because you're talking about exo and endo, obviously in this temperature, in this graph, you're going to have to look at the temperature and the yield, okay, not the pressure. Explain your answer. So the forward reaction. So now, this is a slightly simpler question, I guess. Just take one pressure, okay? Just take one pressure. You don't need to look at all 3 pressure variables, yeah? So just take one pressure values. So let's just take this pressure, okay? As you're increasing the temperature, so as you're going across like that, what's happening is the yield is increasing. So before, at lower temperature, the yield was that much. At higher temperature, looking at this 50 megapascals, the actual yield is higher. Yeah, so that means as you increase the temperature, the yield increases. So what does it say? The forward reaction. Now, I don't know about the forward reaction. I'm going to look at the explanation first, right? And then I'll come to the actual answer of the forward reaction. Okay, so as I'm increasing the temperature, the yield increases. Why? Yield increases meaning the products increase. Therefore, the equilibrium moves to decrease the temperature. So the equilibrium moves to decrease the temperature. Okay, and because we're getting a higher yield, that means the decrease in temperature must be towards the product side, i.e. towards product side. Therefore, the forward reaction, unless they tell you otherwise, the forward reaction is always right, going from reactants to products, yeah, going from left to right. Therefore, forward reaction must be endothermic. Okay, so explanation, well, the forward reaction is endothermic, okay, so it's endothermic. Okay, the explanation is it's endothermic because when you increase the temperature, the yield is increasing. So the equilibrium is moving towards a side which has got lower temperature. And of course that means going forward, yeah, must be endothermic. All right, so the answer, I mean, that's the answer I've just written. So the marks, yeah, in terms of marks, it would be 1 for the actual saying, you know, change in number of moles, it increases, which I've, yeah, so I'm going to write it there, but that would be, must be 1 mark there. Equilibrium shifts in the direction which gives you more moles, okay, towards the products side, okay. So that's 3 marks there, and of course the 3 marks for the next one, the forward reaction is endothermic, so that's 1 mark, you know, 1 mark there, and then the equilibrium moves to decrease. The equilibrium moves to decrease the temperature, yeah, that's 1 mark, i.e. towards the products. Okay, so that's the 3 marks. So 1, 2, and then the third one here, endo. Okay, this question. Yeah, I mean, if I didn't have that equation, it would be sort of, you know, maybe some of you can do it, but I need to see what I'm doing. Don't hesitate to use general equations just to visualize what's going on. Okay, you didn't have to put this 2 in initially. Just have these gaseous reaction products, and then just work through it, yeah, and then think through it as I did. You didn't have to put that 2 in there. Okay. I hope that's clear. It was only 6 marker, but anyway, if it isn't, please let me know, and I won't mind at all. You know, if I have to repeat it, yeah, if I have to re-explain it, not an issue at all. Okay, let me know. Try these questions. There are lots of these equilibria type questions that you can actually have a go at. You know, with different types of graphs, with different variables, different axes, etc. So give it a go and see what happens. Yeah, see if you can explain it. Don't think, oh yeah, I've seen Akib explain it. You know, that's fine. You know, I can explain it. No. Try and explain it yourself, yeah, and try and get those 2 marks for the explanation. Okay, I hope that was of some help. Let me know what you think. Any comments, please write them down in the comments below. Any suggestions, please write them down in the comments below. Okay, keep these requests coming. Yeah, I love it because now I know what people are struggling with. Yeah, so tell me, otherwise I'm just going to have to select questions which I think students are going to be struggling with. So if you make some requests, brilliant, yeah, make some requests in the comments below. Okay, don't hesitate. Okay, right, I'll see you next Tuesday.